Welcome to Part 2, Section 6.2, Rationalizing the Denominator. Okay, so to rationalize the denominator means to remove all radicals from the denominator. And we do this by multiplying both the top and bottom by the conjugate. Let me show you what I mean by a quick example. Let's say we have 3 divided by the square root of 2. Now, the conjugate of the square root of 2 is really the opposite of the square root of 2. But since my denominator is just a monomial, it's just a single term right here, I'm not adding or subtracting anything to it, I can simplify that by just multiplying by the square root of 2 itself. And I have to do it to both the numerator and the denominator. Now when I multiply, the top gives me 3 times the square root of 2. And the bottom, we learned yesterday that if you take the square root of a value, or if you multiply two radicals together, they must have the same index. And if they do that, then you just multiply their radicands. So the square root of 2 times the square root of 2 is really the square root of 4. And I know what you're thinking, we could simplify that square root of 4. And it becomes 2. So my final answer is 3 times the square root of 2 all over 2. Alright, let's start by practicing. Example 1 says rationalize each denominator. And we have the square root of y divided by the square root of 3. So we need to get rid of the square root of 3 from the denominator. Well, in order to do that, multiply both the top and the bottom by the square root of 3. And then you're guaranteed that you will have no more radicals in the denominator. Because what's the square root of 3 times the square root of 3? It's the square root of 9, which I know you're all thinking, square root of 9 is 3. Okay, for the top, we have the square root of y times 3, which is just 3y. I cannot simplify anything with that numerator, so I'm just going to rewrite it over here. Now be very careful with simplifying your overall fraction. The 3 from the denominator, this one right here, cannot simplify with this 3 from the numerator. This 3 in the numerator is underneath the radical, and the 3 in the denominator is not. So no values that are not inside of a radical, or values that are not inside of a radical, cannot be simplified with values that are under a radical. Okay, let's try example 2. Again, we're going to rationalize, but this example has one radical, and it's over the whole fraction. So if you remember from the other day's notes, if you have one fraction underneath one radical, you can really just break that up by doing the square root of both the numerator and a separate square root of the denominator. And so that's what I need to do here. Alright, now I can rationalize. I have a single term in my denominator, and so to get rid of that radical, basically what I need to do is square it. Now I show that I'm squaring it by multiplying it by itself. Okay, I could simplify this numerator right here, but I might have to simplify again at the end, so I'm going to save all simplifying to the very last step. Alright, let's work with the denominator. The square root of 3y times the square root of 3y. Well, really, you multiply the radicands together. So 3y times 3y is 9y squared. So I have the square root of 9y squared, which I can take the square root of 9 and get 3, and I could take the square root of y squared and I get y. Now let's look at the top. So again, I'm doing square roots and I'm multiplying, so that means I just multiply the radicands together. X squared times 3y. So this is really the square root of 3. X squared y. And now I look to take the square root of each factor underneath the radical. Square root of 3 I cannot do, so that's going to stay inside. But the square root of x squared is x. And the square root of y, I can't simplify that one because there's nothing times itself that will give me just one y. So I really end up with x times the square root of 3y divided by 3y. Now I want to ask you a question. Can I simplify these 3y's right here? I'm hoping everybody says no. The 3y in the denominator is not underneath a radical, and so it cannot be in any way combined with the 3y that is under the radical. Okay, let's try example 3. We have the square root of 2x divided by the square root of 3x squared. So, we need to get rid of this 3x squared right here. And if you're thinking we need to square it, you are correct. So in order to square it, I'm going to multiply both the top and the bottom by the square root of 3x squared. Okay, that's as far as I'm going to go for right now. I want you to finish this problem, and I will check it in class the next day. If you have any questions though, come see me before class starts, please. Good luck.